Hello, this is Adam Wu. In this session, we will discuss the following question. Can position tolerance control perpendicularity? This video will take approximately 80 minutes. Now, let's look at a drawing. We have a 14 mm diameter hole. The designer applies a position tolerance of 0.1 and a perpendicularity tolerance of 0.2 to control it. Is there any issue with this specification? Firstly, we need to understand the logic. For this feature, using multiple geometrical tolerances is correct in terms of syntax. For the supplier, all tolerances must be satisfied for the part to be acceptable. When we analyze this case, we also need to go through it line by line. Let's start with position tolerance. Based on a drawing, this is datum A. According to the characteristics of the position tolerance zone, first, the tolerance zone must be perfectly perpendicular to the datum A. Then, it must be located at a basic distance of 15 from datum B and a basic distance of 25 from datum C. The final requirement is that once the part has been manufactured, for example, after this hole is produced, the actual axis of this hole must be lying within the 0.1 position tolerance zone to be considered acceptable. Now, let's zoom in on the tolerance zone. Here, we have the tolerance zone and the axis of the feature. In the ISO standard, the axis is defined as an extracted medial line. For a hole, this means at each cross-section, we constructed a least square circle, and then connect the centers of these circles. This is the extracted medial line. As a result, the axis, in other words, extracted medial line is not perfectly straight, but a curved line. This extracted medial line must lie entirely within the 0.1 position tolerance zone. Please take a close look at this animation. No matter how the feature deforms or bends, the axis of the feature must remain completely within the tolerance zone. Only then can the position tolerance requirement be satisfied. In the ASME standard, the axis of the feature is the axis of the unrelated actual mating envelope. That is, for the actual measured hole, it is the axis of the maximum inscribed cylinder. Note that this axis is a straight line. As long as this straight line lies within the tolerance zone, it is considered acceptable. Now, let's take a look at the animation. In practice, regardless of how the actual axis varies, as long as it lies within the 0.1 position tolerance zone, the position tolerance requirement is satisfied. Now, let's move on to the second feature control frame, the perpendicularity tolerance. What are the characteristics of its tolerance zone? This is the position tolerance zone. All of its degrees of freedom are fully constrained. It is completely fixed in space. Now, this green cylinder represents the perpendicularity tolerance zone. For perpendicularity, the tolerance zone must be perfectly perpendicular to the datum A in orientation. However, its location is not constrained. In other words, the basic dimensions 15 and 25 does not control the location of the perpendicularity tolerance zone. This means the perpendicularity tolerance zone has more degrees of freedom. It can translate freely in space. Ultimately, as long as the axis lies within the green perpendicularity tolerance zone, the perpendicularity requirement is satisfied. Let's first assume that the position tolerance requirement is satisfied. Here we are using ISO definition. This means that, regardless of how the feature bends or deforms, the axis of the feature must lie entirely within the 0.1 position tolerance zone. Also, this tolerance zone is perfectly perpendicular to the datum A. Now, if we consider a perpendicularity tolerance zone of 0.2 in diameter, we can freely translate it in space. As a result, we can always position this perpendicularity tolerance zone of 0.2 in diameter, so it can fully contain the 0.1 position tolerance zone. Therefore, if the position tolerance zone is satisfied, the axis will automatically fall within the perpendicularity tolerance zone. In ASME standard, the conclusion is the same. As long as the position tolerance requirement is satisfied, the feature, the axis, will also fall within the perpendicularity tolerance zone. So, based on the previous animation, we can clearly see that as long as the actual hole satisfies the 0.1 position tolerance requirement, it will also satisfy the 0.2 perpendicularity tolerance requirement. Therefore, the perpendicularity tolerance here is redundant, because if the first feature control frame is satisfied, the second one will always be satisfied as well. So, the second tolerance serves no functional purpose. In conclusion, position tolerance can control perpendicularity. Let's look at this from another more intuitive perspective. If the position tolerance requirement is satisfied, no matter how much the feature tilts or bends, it cannot deviate beyond 0.1 in diameter. In other words, the perpendicularity error of this feature will never exceed 0.1 in diameter. The key point here is that position tolerance zone, just like the perpendicularity tolerance zone, is perfectly perpendicular to the datum A. Therefore, position tolerance inherently controls perpendicularity. Here, it is important to clarify that, according to the standard definition, position equals orientation plus location. In other words, position tolerance controls not only the location of a feature, but also its orientation. Alright, that's all for this session. Before we wrap up, here's a question for you to think about. If we change the perpendicularity tolerance from 0.2 to 0.05, in other words, make it smaller than the position tolerance, would there be any issue with this specification? Feel free to leave a comment and share your thoughts and reasoning.